have an unbalanced reaction and we want to calculate how much nitrogen dioxide is produced in this reaction. So the first thing we have to do, of course, is to balance the reaction. So we have 2 nitrogens, 1 nitrogen, so we want to give ourselves 2 nitrogens. We have 4 hydrogens, we have 2 hydrogens, so we want to give ourselves 4 hydrogens. We have 2 oxygens, we have 2 times 2 is 4, plus 2 is 6. 6 divided by 2 would give us 3. So now we have 6 oxygen. We have not unbalanced our nitrogen or hydrogen, so now we have a balanced chemical reaction. So we have mass of both reactants, so we have a limiting reactant type of problem. So we have to determine which reactant is the limiting reactant. So we calculate the moles divided by the coefficient to determine which is the limiting reactant. So we take our mass, divide by the molar mass, divide by the coefficient, we do the same with oxygen. We're going to divide by the coefficient also. And we're going to pick the smaller amount as our limiting reactant. So once we know our limiting reactant, we use the limiting reactant to do all our calculations. So we're going to calculate how much nitrogen dioxide is formed from our 0.187 moles of N2H4. Then we multiply by the stoichiometric ratio. We want to get mass, so we're going to multiply by the molar mass. That gives us 17.2 grams of NO2. This is our theoretical yield. We have a mass of NO2, the actual yield. That means we can calculate our percent yield. So our percent yield is actual over theoretical, so our 8 grams actual over the 17.2 grams theoretical times 100%. And this gives us 46.5% yield. We also want to know how much is left over of the reactants. Since the N2H4 is the limiting reactant, we're going to have consumed, so we have nothing of that left over. To figure out how much oxygen is left over, we're going to start off with the N2H4, calculate how much oxygen is consumed. So we start with our 0.187 moles N2H4 multiplied by the stoichiometric ratio. And then by its molar mass. And that gives us 18.0 grams. And this is consumed. So to get the leftover amount, we're going to take the original, subtract off the consumed amount, and we have 2 grams of oxygen left over.